chapter triangles of our NCERT book. So this is triangle. What we are going to do in this, we are dealing with the similar triangles. First we'll deal with few terms, and then we come to know what are similar triangles, what are similar objects, or what are similar other than like quadrature and other things, and then we'll deal with the theorems, different theorems, and then the questions based on the different theorems. So this will do. Now starting with the introduction, like you are familiar with the triangle and many of their properties from your earlier classes. In class 9th you have studied the congruence of the triangles in detail. Recall that two figures are said to be congruent if they have the same shape and the same size. So in this chapter we shall study about those figures which have the same shape but not necessarily the same size. So two figures having the same shape and not necessarily the same size are called the similar figures. In particular, we shall discuss the similarity of the triangles and apply this knowledge in giving a simple proof of Pythagoras theorem learned earlier. Now, can you guess how heights of the mountains, say Mount Everest, or a distance of some long objects, say moon, have been found out? Do you think these have been measured daily with the help of the measuring tape? In fact, all the heights and distance have been found out using the ideas of the indirect measurement, which is based on the principle of similarity of the figures. Now, similar figures. Now, like in class 9th you have seen that all the circles with the same radii are congruent, and all the squares with the same sides length are congruent, and all the equilateral triangles with the same sides length are congruent. Now consider any two or more circles as seen in the figure. Here we can see here they are congruent since all of them do not have the same radii. Are they congruent? They are not congruent because their radius is not equal. If the radius is equal, then these circles are said to be the congruent circles. But all of them have the same shape. So shape is same, but the size is not same. So they all are what we call similar. Two similar figures have the same shape but not necessarily the same size. As we can see here, the rectangles or the squares, they have the same shape but they are not having the same size because the sides of each square is different. The measurement is different. So therefore all the circles are similar. In the same way, these squares are similar. Likewise, we can take here the equilateral triangles. All are equilateral triangles but they have the different sides. Okay, so they have the same shape but different size, so they are again similar. They are not congruent. So it means from the above we can say all the congruent figures are similar but the similar figures are not congruent. Now when we say similar means they having the same shape but not the same size. Okay, now can a circle and a square be similar? Can a triangle and a square be similar? These questions can be asked by just looking at these figures. Okay, so now moving forward, now if we see here, what can you say about the two quadrilaters ABCD and PQRS? So look here, ABCD and PQRS. Are they similar? These figure appears to be similar but cannot certain about it. Therefore, we must have some definition of similarity of figures. Based on this definition, some rules to decide whether the two figures are similar or not. So for this, let us look at the photographs of the given figure in 6.3. We can see the same picture but the size is different. So you will note at once say that they are the photograph of the same monument, Taj Mahal, but are in different sizes. Would you say that these three photographs are similar? Yes, they are similar. What can you say about the two photographs of the same size in the same person at the age, one at the age of 10 years and other at the age of 40 years? Are these photographs similar? These photographs are of same size but certainly they are not of the same shape, so they are not similar. So what does a photographer do when she prints photographs of different sizes from the same negatives? You must have heard about the stamp size, passport size and the postcard size photographs. She generally takes a photograph on a smaller size film, say of 35 mm size, and then enlarges it into a bigger size, say 45 mm or 55 mm. Thus, if we consider any line segments in the smaller photographs figure, its corresponding line segments in the figure photographs will be 45 by 35 or 55 by 35 of that of the line segment. So this really means that every line segment of the smaller photograph is enlarged in the ratio 35:45 or 55 or 35:55. It can also be said that every line segment of the bigger photograph is reduced reduce or decrease in the ratio 45 to 35 or 55 to 35. Further, if you consider inclination of the angles between any pair of the corresponding segments, so in the two photographs of the same sizes, you shall see that these inclination of the angles are always equal. So this is the essence of similarity of the two figures in the two polygons. If we again consider this figure, if we see here the sizes of the sides, okay, they are in the same ratio, means if we divide the side of this bigger picture and divide the side of this smaller picture, then we'll get, and likewise this side with this side and this side with this side, we'll get the ratio equal. And here the angles remain same, like this angle is 90, this is 90, this is 90, then this is also 90, this is 90, this is also 90, this is 90, 90. So angle is not changing, only the size is changing here. So two polygons of the same number of sides are similar. First is condition is same number of sides they have. First, the corresponding angles are equal and the corresponding sides are in the same ratio, that are, it means that are in proportion. Same ratio means here proportion. So now we can see here, note that the same ratio of the corresponding side referred as a scale factor or the representative fractions for the polygons. You must have heard the word maps, that is global maps, and the blueprints of the construction buildings are prepared using a suitable scale factor and observing certain conventions. Okay, yes, we have seen in the map. Yes, okay, so with this, now the basic idea of this is clear. Now let us see this figure. The figure is 6.5. So if we see here this figure, they are looking similar. Now let us see whether they are similar or not. Angle A, angle P are equal, angle D, angle S are equal, angle C, angle R are equal, angle B and angle Q are equal. Then we can see here the angles are equal. Now the sides 2.1, 4.2, 2.4, 4.8, 1.5, 3, 2.55. So if you divide, we will get the ratio equal. It means these triangles, these figures are similar, quadrilateral figure similar. If you see this figure, this is 3, 3.5, 3, 3, 3, 3.5, then 3 and 3. Okay, then we can see angles are same. Now, so the two quadrilaters are not similar. You may note that in these two quadrilaters, a square and rhombus of the figure 6.5, corresponding sides are not in the same ratio, but their corresponding angles are not equal. Again, the two polygons quadrilaters are not similar. If we see here, yes, so condition is either the angle should also be equal and the ratio of the corresponding sides should be equal, then only the figures or the polygons are said to be similar. Okay, so now in the same video, now we are going to discuss or just exercise 6. Now dear students, we are going to discuss and solve the exercise 6.1 of the chapter 6 triangles. So the first question in the fill in blanks, fill in the blanks using the correct word giving in the brackets. All circles are dash. Okay, then second is all squares are dash, and the options are given here. Then third and fourth. So looking at the first one, all circles are similar. All circles are similar because in case to be congruent, in case of congruent, they should have radius should be equal. So it means all the circles are similar. Then we see all the squares. In the same way, all the squares are also similar because for congruent, they should have the same length of the each side. Then all dash triangles are similar, isosceles or equilateral. All the equilateral angles are similar. All the equilateral angles are similar because they have the equal sides. Okay, so then coming to the next, we have the fourth one. Two polygons of the same number of sides are similar and their corresponding angles are, so their corresponding angles are equal and their corresponding sides are in proportion. Okay, so it means their angles should be equal and then their sides should be in proportion. Okay, this we have already discussed. Then moving towards the question number 2. If we see in the question number 2 what we have, in the question number 2 they are saying give two different examples of a pair of similar figures. As you can see, both are the triangles, sides are 1 is 2 is 1 is 2 is 1 is 2, whereas the corresponding angles are equal. So we can see these are similar figures. These are similar figures. Okay, then we see to the then we see here also 1 2 1 2 1 2 1 2, so ratios will be equal, so it means they are similar. Then moving towards the second part, that is they are saying yes non similar. If you see here in this figure, what we can see it is a square or rectangle, this is a trapezium. Okay, so they can't be similar because we can't take their ratio of their sides proportion. And then one more example you can take, like we are taking a triangle, and then we are taking a parallelogram. So again the same thing is there, that is triangle and a parallelogram, they are not similar because first thing is they are not looking like similar to each other. Okay, so there's a different reason because one is a triangle and this is a quadrilateral. Then question number 3 is about state whether the following quadrilaters are similar or not. So if we see here in this question, so the side of the quadrilateral PQRS and ABCD, if we see here the ratio is 1:2, the corresponding angles of the quadrilaters are not equal. So the sides are in the ratio, but these angles are not equal. They are like these all are 90-degree angles, but these are not all angles 90 degrees, so they are not equal. So it means these equilaters are not similar, though they have the equal side, but still they are not similar. Reason is, for example, this is a, we call this a square, this is a rhombus. Okay, so sides are equal, we can take sides are equal, and then here we can take the sides are in ratio, but the corresponding angles are not equal. So with this we have come to the end of this exercise.